If the function is differentiable on an interval I, then the range f dash of I of f on I, either it is an interval and or a singleton sum. We have to prove that if the function is differentiable on an interval, like that this interval is closed interval, open interval is, and so on, then the derivative of this on interval, it is also an interval. It is also an interval or a singleton set, otherwise not. Okay, not the existence of this function, derivative of the functions of interval, right? Now we have to prove that f dash of I, derivative of the interval of the functions, it is always an interval, right, or a singleton set. But firstly we have to prove that it is an interval, right? Now what is the definition of the interval? If x1 and x2 is in capital A, right, capital A is an interval which is f dash of I, which we have to always learn this, remember this. And if this is, then A is an interval, so x is in between x1 and x2. This always implies that x is in capital A, then we have to say that A is a interval, right? Now let us take P1 and P2 is in capital A. P1 and P2 for which types? P1 and P2 is in f dash of x1 type and f dash of x2 type. X1 and x2 which is in I, right? Now what definition, let x1 and x2 is less than x1 is less than to x2, because it is in interval of I, the functions domain. Now then P1 and P2, P is in between this. We have to prove that P is in capital A, right? So f dash of x1, f dash of x2, it is P is in between this. So this implies that there exists C is in x1 and x2, such that there exists C is in, which is in I, such that f dash of C which is equals to P. It implies that by mean value theorem, so P is equals to f dash of C, and C is in x1 and x2, which is contained in I, and C is in, what we have says that C is in I, and we know that A is equals to f dash of I. We know that A is equals to f dash of I. We let this, right? Now C is in I, and this implies that f dash C is equals to P, and f dash C is equals to P, and A is equals to f dash of I. This implies that P is in capital A. Okay, P is in capital A, and if P is in capital A, this implies that A is an interval.